All right, this is AP Chemistry topic 3.4, the ideal gas law. So before we get into the ideal gas law itself, let's talk about properties of gases and how we represent them with units and with variables. So we first got pressure, which we abbreviate with capital P. That is usually found in units of torr or atm. Now you'll notice that I have this boxed. That's because this is going to become the most important unit for us moving forward, and we're often going to have to convert into that, and you'll see why in just a minute. Then we have volume, represented with capital V, milliliters or liters. Please remember that there are 1,000 milliliters in a liter, so to convert that, you bump your decimal 3 times. Moles, which is represented with a lowercase n, that is just in moles, but often we convert into and out of grams using that. And then temperature is going to be found in degrees Celsius or Kelvin, abbreviated T. As a reminder, the relationship between degrees Celsius and Kelvin is you just take your degrees Celsius and add 273. So first, let's look at the combined gas law. This is found on the AP equation sheet. So this is written as P1V1 over T1 is equal to P2V2 over T2. This is used to determine the impact of a change in conditions. So for example, if you have a certain set of conditions at a pressure, volume, and a temperature, and you do something like increase the pressure, then you could figure out how the volume is impacted. Now, oftentimes we do these at a constant temperature. If that's the case, then your temperature would divide out on both sides, and you really only need to do P1V1 equals P2V2. You could do the same thing if it's at constant pressure. You can ignore the pressure, and then you'd have V1 over T1 equals V2 over T2, or you could do a constant volume, P1 over T1 equals P2 over T2. Again, this is on the equation sheet, and so you can use this, and this is if you have a set of conditions to start with and then a second set of conditions after you've undergone a change. Okay, so the ideal gas law itself is PV equals nRT. Now you use the ideal gas law to calculate any property if you know the other 3 properties. So let's define a few things here. So P is still pressure, and we use it in ATM. V is volume, we use liters. N is moles, it has to be in moles. T is temperature, and that's in Kelvin. R is a new thing here. This is called the universal gas constant, and it has a constant value that will not change unless you change the units. So this is 0.08206, and the units here are in liters atmospheres per mole Kelvin. This is important. This is why all these other units must be this, because your units for pressure, volume, moles, and temperature must match your units of R in order for this to work out correctly. So the biggest thing to pay attention to here is to make sure that your units are correct. And if they're not matching your units of R, then you might need to do a unit conversion before you plug in and get started. Okay, so this section has a lot of equations, but this is an equation that is useful but is not found on the equation sheet. So this is how you would calculate molar mass if you know the density of a gas. So in this case, we have this M, and this M stands for molar mass, which remembers grams per moles, and that equals density times R times temperature divided by pressure. Remember that density is grams per liter. So basically, this is an application of the ideal gas law, and you could plug in, rearrange, and solve for this if you just know the ideal gas law and you know what molar mass is, you know what density is. But this is a little bit faster if you're just trying to relate molar mass and density. So there's a cute little mnemonic for this. If you remember that molar mass cat puts dirt over P, remember how cats always bury what they do in the litter box. So then that helps you to remember this DRT over P, molar mass cat. Okay. So, but again, your units need to match the units of your ideal is your universal gas constant here. Finally, in this section, we talk about partial pressure. So partial pressure is the idea that if you have a mixture of gases, each individual gas contributes some amount of pressure to the overall total pressure. So then how do you figure out what amount of pressure they contribute? Well, you need to look at the mole fraction. So this is mole fraction, so this would be for pressure or for component A. And so the mole fraction of A is equal to the moles of A divided by the total moles. It's literally a fraction of the moles, right? You can also think of this as the same as a ratio or a percent. And so then what you do is you take that and you multiply by the total pressure, and that would give you the pressure of A. So in other words, what that means is that if component A is 70% of your mixture, then that is contributing to 70% of your total pressure. So that's it. That's it for this topic. Oh, by the way, all of these are on your equation sheet. And so I would do some practice plugging in and solving. I really like chemquiz.net to do that. You can head on over there and look at their gas practice problems. It's a really good site. Highly recommend it. And I'll be back very soon with our next topic.